Hi everybody. We are going to be doing another cumulative distribution function example. And it is going to have to do with rolling two fair six-sided dice, which is an example that we are really familiar with. And we're going to let x be the random variable that gives the first die minus the second die. So we talked about this example in either the random variable or probability mass function video, or both. So what we want to do here is find f of 0, and remember that's the probability that x is less than or equal to 0, and find f of 3/2. That's the probability that x is less than or equal to 3/2, and then we want to write out the whole cumulative distribution function. All right, let's go ahead and remind ourselves what can happen with this situation. Okay, so we already mapped out a little bit of this, but possibilities for x. So say we rolled like 6 and then 1. Well, that would give us 6 minus 1, x is 5. Okay, we can also get a difference of 4, 3, 2, 1, 0, or -1, -2, -3, -4, or -5. So this one, right, the one in the middle, 0, is when they're all the same. So like 1, 1, 2, 2, all the way down to 6, 6. -5, right, is when we have 1 minus 6. Okay, and we can fill in the other ones. So 4, we would have, what, if it's 6, we could have 6 and 2. If it's 5, we could have 5 and 1. And then those are going to be flipped around. 2, 6, 1, 5. 3, 6 and 3. 5 and 2, 4 and 1, and those are going to be flipped around to give you -3. Okay, and then 2, we're going to have 6, 4, 5, 3, 4, 2, 3, 1. -2, all of those flipped around. Oops. 3, 5, 2, 4, 1, 3, and then 1, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, and then we have them flipped around here. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Okay, so we just mapped out all of the possibilities for this random variable x. That is a lot of information. So let's think about our first question, f of 0. F of 0, that is the probability that x is less than or equal to 0. And if x is negative, right, so it could be 0, -1, -2, all the way down to -5. So that's any of these options over here. So we want to count up, right, how many options those are. And let's see, there's 6 here, 7, 8, 9. Okay, so there's 6 options here, 5 here, 4 here, 3 here, 2 here, and 1 here. So that is going to be, what, 10... 18, 20, 21. Okay, should be 21 out of 36. And let's just double check, right, that we did get all the options. There's supposed to be a total of 36. So let's see. All right. So basically 21 and then 9, 10. Yeah, okay, so this is all of the options mapped out correctly. All right, so f of 0, probability that x is less than 0, is 21 over 36. And now we want to think about f of 3 halves. That is the probability that x is less than or equal to 3 halves. And of course, we can't have our random variable be 3 halves, right? It's only whole numbers. It's not going to be 1.5. But it could be any of the numbers that we talked about before, and 1 is also less than that. So we're going to get the 21 over 36 that we had before, plus the number of options for 1, which if we scroll up, there was 5 options there, so plus an additional 5 more over 36 for 26 over 36. Great. All right. Now we want to go ahead and write the entire cumulative distribution function. And remember, we sort of want to start from the bottom up. So basically, here's all the values that we could have for x. And if we're talking about anything less than -5, it's going to be 0. Okay, so -5 is where we're going to want to start. Okay, so we're writing out the whole cumulative distribution function. All right, so f of -5, remember that's the probability that x is less than or equal to -5. It's never going to be smaller than -5, but it will be equal to -5 one time. So that is going to be 1 out of 36 possibilities. And now, right, it's going to stay the same. There's going to be no new possibilities until we go up to -4. Okay, so less than or equal to -4, right? That's where it could be -4 or -5. So that's this option here and that option here. And that is a total of 3 over 30. Whoops, that's not correct. That is not that one. The single option over here and the 2 here. So we get, let's make sure we do this correctly. The 1 over 36 of last time plus 2 over 36 for a total of 3 over 36. Okay, and then f of -3. This is less than or equal to -3, so now that's the possibilities of -3, -4, or -5. So now we have the 3 that we had before, the 3 options here and the 1 option here, and we got the 3 options here where it's equal to -3. Okay, so we're going to add those all together. So what's sort of happening is it's kind of adding up all of the values of the probability mass function, starting with the smallest, right? It was just the probability of -5 first, and then these 2 added together, and then these 3 added together, and it's going to keep going in that fashion. So f of -4, whoops, that's not the direction that we want to go. -2. Probability that x is less than or equal to -2. So it could be -2, -3, -4, or -5. And let's see, so that's going to be, it's 1, 2, 3, and then there should be the options where it's -2. There are 4 options there. Okay, 4 over 36 for a total of 10 over 36. And do the next one, -1. Probability that x is less than or equal to -1. We're going to get all of these that we had, right? So that total of 10 over 36 plus the number where it is -1 and there's 5 options when that difference is -1. So we get plus 5 over 36 for a total of 15. All right, 0. Probability that x is going to be less than or equal to 0. So it could be 0, -1, all the way down to -5. All right, so that is going to be, right, everything from the previous one. And then the new value is when it's equal to 0. And it's equal to 0 6 times out of 36. 6 out of 36, which is 21 out of 36. And that's actually one that we already figured out. Okay. Now we keep increasing the value by 1, probability that x is less than or equal to 1. So now it could be 1, 0, all the way down to -5. So it's all of the previous ones plus the probability that it's 1. And it is 1 5 times. For a total of 26 out of 36. And then f of 2, probability that x is less than or equal to 2. So we're going to get all of the previous ones. Okay. So this one is the probability, right, that it's 1, 0, -1, down to -5. And then the new one is the probability of getting 2. And if we look up, you'll see that's 4 options out of 36 for a total of 30 out of 36. Okay. F of 3, probability that x is less than or equal to 3. So remember, that's all of the previous ones. So this is, right, -5, -4, up to 0, 1, or 2. And then if we look up at 3, okay, there is 3 out of 36 options when it gives us 3. So we add that together and get 33 out of 36. And if you notice, right, as we're getting sort of more and more possible values of x under this umbrella, our probabilities are getting higher and higher because most of the values of x are 3 or smaller, right? From -5 to +5 is the range, and most of those are 3 or smaller. Okay, so stay with me. We only got 2 more. Probability that x is less than or equal to 4. Well, that's all of the previous ones. And if we look, the chances of it being 4, x equals 4, that's 2 out of 36 chances. So that's 35 out of 36. And then f of 5, the probability that x is less than or equal to 5. Well, so we can just remember here, right, x is always 5 or less. So we should get 1, but we can sort of see that that happens. It's going to be all of the previous probability. And then we want here, right, the probability that we get x is equal to 5, and that's 1 out of 36 options for a total of 36 out of 36, which is equal to 1. Okay, and then what happens is we've got a couple things here. So f of q, anything bigger than 5 is just going to be 1. Okay, so it's 1 if q is bigger than or equal to 5. And it's going to be 0 if q is smaller than -5, right? So the probability of us getting something that's really truly less than -5 is 0 because x never takes on that value. So let's write that down. This is less than -5. All right. And there is the cumulative distribution function for this example. Okay, you guys, there's actually one other thing that we want to talk about. So remember we talked about this stair-steppy thing. Really, what's going to happen here is that, all right, so we're going to get 0, right, if q is less than -5. And then we get, no, that's not what we get. We get 1 out of 36 if we bump up to -5, but we haven't yet bumped up to -4, right? Because it doesn't change again until after we get to -4. Okay. And then it's 3 out of 36 if we've bumped up to -4, but not yet -3. Let's see, it's 6 out of 36 if we have bumped up to -3, but not up to -2. It's 10 out of 36 if we have bumped up to -2, but not -1. It's 15 out of 36 if we're here, right? So we have bumped up to -1, but not 0. If we're above 0, it bumps up to 21. If we're above 1, it bumps up to 26. If we are above 2, it bumps up to 30. And if we're above 3, it bumps up to 33. If we are above 4, it bumps up to 35. And it's just 1 if Q is greater than or equal to 5. So we end up with this like ginormo piecewise function. So this is sort of like, remember at the beginning we did f of 3 halves, and we found that was, let's see, 21 over 36 if memory serves, and that kind of matches up with this, right? If 3 halves is in between 1 and 2, oh, we got 26. Whoops. But we got 26 over 36. So it only really changes at these stair-step things, but the cumulative distribution function is defined on all of R. So I can input any real number, even if it's not a number that x can be, and I still get a number out of this function.